In this video, we're going to take the derivatives of several functions using logarithmic differentiation. So for our first function, we have y equals the square root of x cubed times x plus 3. So the first thing we want to do is take the natural log of both sides. So when we do that, we get the natural log of y equals the natural log of the square root of x cubed times x plus 3. And now we can use the properties of logarithms to keep simplifying this until it's really easy to take the derivative. So we get the natural log of y times, this can all be written as the natural log of x cubed times x plus 3 all raised to the 1/2 power. So that means we can use the property of natural log, or property of logarithms, to bring this 1/2 out front and get the natural log, or 1/2 the natural log of x cubed times x plus 3. And now we have the natural log of a product of things. And so again, we can rewrite this as 1/2 the natural log of the first function plus the natural log of the second function. Okay, and then again, I'm just going to erase this. We have the natural log of x cubed. We could again bring this out front, and instead of natural log of x cubed, have 3 times the natural log of x. So now we're ready to take the derivative of both sides. So if we do that, we'll get 1 over y times dy dx. So this is kind of like using implicit differentiation on the left-hand side. So if you need a refresher in implicit differentiation, I have a video on that, or you could go back and brush up in your textbook. So then we take the derivative of the right side. So we have 1/2 that comes out front times the derivative of these two terms, which is just going to be 3 times the derivative of natural log of x, which is just 1 over x, plus the derivative of the natural log of x plus 3. So we just do 1 over the argument. So 1 over x plus 3 times the derivative, which is just 1. So the derivative of x plus 3 is just 1. And then we need to solve for dy dx. So dy dx, we'll clean this up a bit and have 1/2 times 3 over x plus 1 over x plus 3. And then we need to multiply by y to get it to the other side. But our y is just our original function. So we'll multiply by the square root of x cubed times x plus 3. And if we want, we can move this 1/2 inside and get 3 over 2x plus 1 over 2x plus 6, all times the square root of x cubed times x plus 3. So next function, we have y equals 1 over x times x plus 2 times x plus 3 squared. So we want to start off by taking the natural log of both sides. So we get the natural log of y equals the natural log of 1 over x times x plus 2 times x plus 3 squared. So this is a natural log of a quotient of a product. So we can use properties of logs to rewrite this. So we'll get the natural log of the numerator, which is natural log of 1, minus the natural log of the denominator, but that's just a product of things. So we can write this as minus the natural log of x plus the natural log of x plus 2 plus this 2 is an exponent, so it can come out front, times the natural log of x plus 3. And now we can take the derivative. So we get 1 over y times dy dx. The natural log of 1 is just 0, so it goes away. And then we get minus the derivative of ln of x is just 1 over x. And then the derivative of natural log of x plus 2 is 1 over x plus 2 times the derivative of x plus 2, which is just 1, plus 2 times the derivative of ln of x plus 3 is just x, 1 over x plus 3 times the derivative, which is just 1. So we get dy dx equals minus 1 over x plus 1 over x plus 2 plus 2 over x plus 3, all times y, which is just 1 over x times x plus 2 times x plus 3 squared. And then if you want to get a common denominator and bring all this together, you will get minus 2 times 2x squared plus 6x plus 3 all over x squared times x plus 2 squared times x plus 3 squared. So this next function, we have y equals x cosine x divided by the square root of cosecant x. So we're going to start by taking the natural log of both sides. Get the natural log of y equals the natural log of x cosine x over square root of cosecant x. And now on the right hand side we have a product and a quotient inside of a logarithm, so we can write the natural log of the denominator, which is going to be the natural log of x plus the natural log of cosine minus the natural log of the denominator, so natural log of cosecant raised to the 1/2. So we can rewrite that, natural log of x plus natural log of cosine x minus 1/2 the natural log of cosecant x. And now we're ready to take the derivative, so we get 1 over y times dy dx, as always. The natural, or the derivative of natural log of x is 1 over x, plus, again, we'll get 1 over cosine x times its derivative minus sine x, minus 1/2 the natural log of cosecant, 1 over cosecant times its derivative, which is minus cosecant x cotangent x. Okay, and now we can simplify. So we have dy dx is going to equal 1 over x minus sine x over cosine is tangent, so tangent x, plus, or cosecant and cosecant will cancel, the minus signs will cancel, and we'll get cotangent x over 2. And then we had to multiply our y to the other side, so that's going to be x cosine x all over square root of cosecant. The next function, we have y equals the square root of t plus 2 to the 12th divided by 3t plus 4 raised to the 6th. So we will take the natural log of both sides. So this is going to be t plus 2 to the 12th over 3t plus 4 to the 6th, all raised to the 1/2. So we'll rewrite this as 1/2 the natural log of a quotient. So this will be natural log of t plus 2 to the 12th minus natural log of 3t plus 4 to the 6th. And then again, you can bring down these exponents and get 1/2 12 ln of t plus 2 minus 6 times ln of 3t plus 4. And now we're ready to take the derivative, so we get 1 over y times dy dx for the left side. And then 12 over 2 is just 6 times the derivative of natural log of t plus 2, which is 1 over t plus 2 times the derivative of t plus 2, which is just 1. Put that in parentheses. And then minus 6 over 2 is just 3 times the natural log of derivative of natural log of 3t plus 4, which is 1 over 3t plus 4 times the derivative, which is just another 3. Okay, and so now this is going to simplify to 6 over t plus 2 minus 3 over over 3t plus 4. And when we multiply by y to isolate our dy dx, we get 6 over t plus 2 minus 3 over 3t plus 4, all times the square root of t plus 2 to the 12th over 3t plus 4 to the 6th. Next function, we have natural log of x times y equals e to the x plus 2y. So, first thing we want to do is write the left-hand side. Since it's a natural log of a product, we want to write that as a sum of natural logs. And then I can write the right-hand side as e to the x times e to the 2y, since the exponents will just add. And now I can isolate my natural log of y. The natural log of y, since we already taken the natural log of y, we don't have to take the natural log. We can just start by taking our derivative. And so we're going to do this using implicit differentiation. Again, if you need to go watch the video on that to brush up, you can do that. And we'll get 1 over y times dy dx equals, this is a product rule. So we have the derivative of the first, which is just e to the x, times the second, which is just e to the 2y, so we get the same thing, plus the first times the derivative of the second, so we'll bring down a 2 times e to the 2y, and then we need to multiply by the derivative of y with respect to x, so that's just y prime, and then minus the derivative of ln of x, which is just 1 over x. So now I need to get my y primes on one side. So on the left-hand side, I already have y prime over y, so I just write my dy dx as y prime. And I need to move over this other term that has a y prime in it. So I'll subtract it and get 2e to the x plus 2y. So I'll go ahead and redistribute those exponents, times y prime equals e to the x plus 2y. There's no reason for me to keep it the way it is, minus 1 over x. And now if I isolate y prime, I'll factor out y prime. I get y prime times 1 over y minus 2e to the x plus 2y equals e to the x plus 2y minus 1 over x. And then solving for y prime, I get e to the x plus 2y minus 1 over x divided by 1 over y minus 2e to the x plus 2y. And by simplifying, by multiplying by xy on both sides, or on top and bottom, you can write this as xy e to the x plus 2y minus y all over x minus 2xy e to the x plus 2y. The next function, we have x to the y equals y to the x. So we need to take the natural log of both sides. Now we can use the property of logs. So to bring down our exponents, y times the natural log of x equals x times the natural log of y. And now if we take the derivative of both sides, so we'll again use implicit differentiation, we'll get the derivative of the first, which is y prime, times the second, ln of x, plus the first times the derivative of the second, which is just 1 over x, equals the derivative of the first is just 1 times the second, ln of y, plus the first times the derivative of the second, which is 1 over y times dy dx, or just y prime. And so now we want to again get both of our y prime terms on both sides. So I'll get y prime times ln of x, And then when I move this term over, I'll factor out y prime and get x over y. Then I will move my y over x over, so I get ln of y minus y over x. And now, solving for y prime, get ln of y minus y over x over ln of x minus x over y. And now you can do some simplifying by multiplying by factors of x and y, and you will get x times y times ln of y minus y squared all over x, y, ln of x minus x squared. If you want, you can factor out a y on top and an x on bottom and get y equals, or y prime equals y times x ln y minus y over x times y ln x minus x. The next function, we have y equals 3 raised to the x. So we can start by taking the natural log of both sides. So ln of y equals ln of 3 to the x. And use our property of natural logs. So ln of, or x times ln of 3. So now we can take the derivative of both sides. So 1 over y times dy dx equals just ln of 3 since it's a constant. And so dy dx is just y times ln of 3, or 3 raised to the x times ln of 3. So our next function, we have y equals 7 raised to the square root of x. So we take the natural log of both sides and get ln of y equals ln of 7 raised to the square root of x. And so using our properties of logarithms, we get square root of x times the natural log of 7. And so in order to take the derivative, I want to write this as x raised to the 1/2 times ln of 7. And then taking the derivative, I get 1 over y times dy dx equals ln of 7 is just a number, so it comes out front. And then the derivative of x to the 1/2, I'll bring down my 1/2 and subtract 1 from my exponent, making it minus 1/2. And I will get the natural log of 7 over 2 square root of x. And now I need to multiply by y. So my dy dx is going to be y times everything I have over here to the right. So that is just y ln of 7 over 2 square root of x, or 7 raised to the square root of x power times ln of 7 all over 2 times the square root of x. The next problem, we have y equals x raised to the 2 minus e power. So we take the natural log of both sides. We have ln of y equals ln of x raised to the 2 minus e. But we can use the property of natural logs to bring this down. So 2 minus e all comes down times ln of x. And now if we take our derivative, we get 1 over y times dy dx equals 2 minus e is just a number, so it comes out front. Derivative of natural log is 1 over x. And if we multiply by y to isolate dy dx, we get 2 minus e times, or over x, times our y, which is x to the 2 minus e, or you can write this as 2 minus e, keep our number out front, and we can break up this exponent as x squared times x to the minus e all over x. And so that's going to lead to one of these x's canceling, and we're left with 2 minus e times x to the 1 minus e. So we have x to the 1 times x to the minus e. We can bring those together as x raised to the 1 minus e. Okay, in our last problem, we have y equals 3 raised to the x squared. So if we take the natural log of both sides, I can use the property of natural logs to bring this down. So I have x squared out front times the natural log of 3. And so if I take the derivative of both sides, I get 1 over y times dy dx equals the square root of x squared, which is just 2x, and then this number comes out. So now I isolate dy dx, and I get, I multiply by y, so I get 3 raised to the x squared, all times 2x ln of 3. And if I wanted, I could bring this 2 inside of this natural log. So this could also be written as 3 raised to the x squared times x natural log of 9. So I hope this video helped you see how you can use logarithmic differentiation to find the derivatives of some more complicated functions. And I'll see you in the next video.